Calculus Math 11. Dance. Dance.
The ambiguous case.
Alright guys, here again are the solutions to the sheet that I gave you in class today that we were working on. Let's have a go. So again, you already know this is an ambiguous case situation, but to recognize whether or not it is, remember that you need to be given an angle and two sides that are not right around the angle on either side. One side opposite, which you can see you've got here because angle F and little f, and then a second side length as well. So when you've got that information, the diagram I would like you to use as your standard ambiguous case triangle diagram is one like this. And you always put the information in the same places. The angle that you're given, in this case F, 40 degrees, goes down here on the left. It can't be either of the other places because those are all angles that could change in their measurement. This one's locked in at 40. Its opposite side then, little f, is the 18 here or the 18 here. So it creates an isosceles triangle on the right hand side. And then the 22.5 inches, that can't be on the bottom because there's two possible lengths on the bottom. That 22.5 has to be up here, 22.5 inches. These are all inches. If that is little t up there, then that means angle T is either here or here. And I'd like you to number them T1 and T2 just like that. Have one on the outside because that's the first one that we're going to be finding, and then angle W up here at the top. Technically W1 is all of this and W2 is just the little bit here leading down to T2, but we'll just label it as W. Now that you've got the large diagram of both triangles, I'd like you to do another diagram that's just F, T1 and W, so we can just consider that triangle on its own first. So F, 40 degrees, T1 we don't know, this is 18, this is 22.5. First thing we can solve for is angle T1, and so we'll do that with sine law. Sine of angle T over little t equals sine of angle F over little f. And that means the sine of t is going to be 22.5 times sine 40 all over 18. Grab my calculator. 22.5 sine 40 over 18. That's the sine of angle t. So to get angle t, I'm going to inverse sine all of that amount. So I get angle t is approximately 53.5 degrees. 53.5 degrees. Now that I've got that, 53.5 degrees, angle W is dead simple because I just need to subtract from 180. So angle W is 180 minus 40 minus 53.5. 180 minus 40 is 140, so 140 minus 53.5, 86.5 for angle W. We've got that. The only thing missing now is little w, the side length down here. We'll solve that using sine law again. Just going to scroll down a little bit here, make some space. Little w over sine w, which is 86.5, equals, let's go with f because that was given information, 18 over sine 40. Solving for little w, multiply both sides by sine 86.5. So 18 sine of 86.5 over sine 40 degrees. Grab my calculator. 18 sine 86.5. Close the brackets. Divided by sine 40. 27.95. That gives me then approximately 28 inches. So I've got this triangle solved. no more question mark, 28 inches. This possible triangle, done. Let's look at the other possible triangle, the skinnier triangle. The one that looked like this. F is 40, 22.5 for little t, 18 for little f. We've got W there. We're now looking at T2. Remember that WT1, T2 is an isosceles triangle, and we found that this was 53.5, which means that this angle is 53.5. So we've got 53.5 right here. So to get angle T2 on this triangle, we're just going to say that angle T is 180 straight line minus 53.5. 53.5 is the reference angle here. This is like a second quadrant angle. 180 minus 53.5 is going to be 126.5 degrees. Now we've got angle F and angle T. We want to get angle W. Same thing. We're going to subtract from 180. Let's take 180 minus 40 minus 126.5. 13.5 for angle W. And now we just need to solve for little w, and we'll do that with sine law again. W over sine W, but in this case W is 13.5 degrees, equals F, 18, over sine F, which is sine 40. W equals, back to my calculator, 18 sine 13.5, close the bracket, divided by sine 40. 6.5. Maybe I could write this down here yet. 18 sine 13.5 over sine 40. This means W is, what did I say? 6.5 inches. So we've got both possible triangles solved here. Angle T, angle W, and little w. Angle T, angle W, and little w. Done. Okay, let's look at the other question on the back side. Again, we're given angle A and we're given little b. We're not given side A, but we're asked information about side A for making ambiguous cases and what have you. So angle A of 30 degrees will sit here, and little b, that's the other given information, so that'll be 16 centimeters. That's over here. That means this point up here is going to be C, and my angle B is going to be somewhere here down on the bottom. Now the first question is, what's true about little a so that there is no possible triangle? Well, if little a is just a little short piece that hangs down here like this, it's clearly not long enough to reach down to the bottom to be a triangle here. There's no triangle that can exist. What's the shortest possible length you could have for a? The shortest length would be if you brought A down to here at a right angle. That would be the shortest. Anything shorter than that, it's not going to work. Could we get that measure? Sure. This triangle ABC that I've drawn right now is a right triangle. We can use grade 10 trigonometry for this. Sine of 30 equals opposite over hypotenuse, so A over 16. So this is 16 sine 30 equals A. I could type that in my calculator, but remember, in your 30, 60, 90 triangle, 30 degrees is up here, opposite and hypotenuse is 1 over 2, so that sine of 30 is 1/2, which means 16 times a half. A is equal to 8. That's the height. That's actually the answer to question B. There's only one possible triangle, and it's a right triangle. That's the height here. That's where A is equal to 8 centimeters. Then there is no possible triangle ABC. That's anywhere where A is less than 8 centimeters. All right? If you make this 7.9, now A is too short, just goes to there, no triangle. Once A is 8, bang, right triangle, we've got that one situation. Next part, there are two possibilities for triangle ABC. The ambiguous case.
The ambiguous
This
case.
situation will be where A is slightly longer than that length of 8. So 8 is less than side length A. But we want to keep increasing A. We can make it longer and longer and longer, but the maximum length it could be would be up to a length of 16, but not equal to 16. Once it gets up to 16, then there is only one possible triangle. So A has to be less than 16, but greater than 8. And then going on further, there is one triangle. I suppose actually there is the possibility that it could have a right angle up here at C. That's not what I was referring to. I just meant that there is one triangle now larger, and this would be the case where A is greater than 16, because then you would be looking at something like this, where A is really long and stretched out that way. So you've still got 16 and 30 degrees here, and now A is something large like 30, 40, etc.